Hi everyone, welcome once more to this YouTube channel, Best Science Brain YouTube channel. Today we're looking at solution to NABTEB November GCE General Mathematics. If you are not subscribed to the channel, move up to the channel's name, Best Science Brain. Above the channel's name, you see the subscription icon. Tap on the subscription only once and get subscribed to the channel. If you are writing NABTEB examination, NECO, WAEC, GCE or WAEC examination, internal May, June, JAMB exam, if you are in secondary school, or if you are in first, second, or third year of higher institution, subscribe to the channel for tutorials and for solutions and revisions on past examination questions. So today we're looking at NABTEB November GCE Mathematics, General Mathematics. We'll start with session B. Session B, and we're going to look at 4 questions for session B. Session B, we're going to look at focus. Session B, the instruction there is answer a maximum of 4 questions. Okay, students that are doing secretarial studies and business studies are supposed to answer 2 questions for session B, while other students will answer a maximum of 4 questions from this session B. So we're going to look at 4 questions for session B. So we'll start with number 7. 7 is that says the sum of the second and fifth term of an arithmetic progression AP is 42. If the difference between the sixth and third term is 12, find the I common difference, II first term, III 20th term, IV sum of the first 20 terms. We'll now go to the solution. So we'll look at the first question that says the common difference. Now, the nth term, that is Tn of an AP given by A plus n minus 1 bracket, then D. Then the sixth term, get an equation for the sixth term, that is T6 equal to A plus, where n is now 6, bracket opens, 6 minus 1, then bracket closes D. Then we now have T6 equal to A plus 5D, equation 1. Then T3, which that is the third term, will now become A plus, bracket opens, 3 minus 1, bracket closes D, making taking n as 3. So that gives us T3 equal to A plus 2D. That becomes equation 2. So we have to get an equation for term 6 and term 3. I remember from the equation we are told that if the difference between the sixth and the third term is 12, so we have to first of all formulate an equation for the sixth and the third term. So the sixth term is equation 1 here, the third term is equation 2. Then subtract equation 2 from equation 1. That is, subtract equation 2 from equation 1. That is term 3 from term 6. So we have the expression T6 minus T3 equal to A plus 5D minus, bracket opens, A plus 2D, bracket closes. A plus 5D is term 6, A plus 2D is term 3. And that will give us 12, because we are told the difference between the sixth term and the third term is 12. Then we continue. Term 6 minus term 3, that will come down. A plus 5D open the bracket, we will now have minus A, then minus times plus 2D give you minus 2D equal to 12. Then picking like terms, A eliminates A minus A is 0. Then 5D minus 2D give us 3D, which is equal to 12. Then D equal to 12 over 3, giving us 4. So the common difference is 4. Now going to number 2, or II, we're asked to do for the first term. To get the first term, that is number 2, term 2, Tn, using the same formula for any term, Tn equal to A plus bracket n minus 1 bracket D. Then term 2, that is T, when n is 2, we now have A plus 2 bracket 2 minus 1 bracket closes D. So the equation for second term becomes T2 equal to A plus D, equation 1. We still have to formulate an equation for the fifth term, that is term 5, equal to A plus bracket opens 5 minus 1 bracket closes then D. Then T5 becomes A plus 4D, equation 2. Then we are told from the equation, the first sentence, the sum of the second term and the fifth term of the AP is 42. So we now say adding equation 1 and 2. That means we're adding now second term and fifth term. We now have A plus D, that's second term, plus A plus 4D, that is fifth term, equal to 42. Then pulling the like terms together, A plus A gives us 2A. Then D plus 4D gives us 5D, equal to 42. But from the number 1, we got our D as 4. So we'll now substitute 4D with 4. We'll now have second line, 2A plus 5 times 4 equal to 42. Then 2A equal to, collecting like terms, because 5 times 4 is 20. 2A equal to 42 minus 20, which give us 22. Then A first time becomes 22 over 2. That will give us 11. So that is the solution to this problem. We'll now go to 7 triple I that says find the 20th term. We still use the near term equation Tn equal to A plus bracket opens n minus 1 bracket closes D. This time around n is 20. A is 11 from the previous questions or solutions, and then D is equal to 4. So T20 equal to 11 plus 20 bracket opens 20 minus 1 bracket closes then 4 equal to 11 plus 20 minus 1 is 19, then multiply by 4. Solving out, term 20 becomes 11 plus 76. 76 is 19 times 4, that is 76. Adding them together, 11 plus 76 gives us 87. So term 20 is 87. Going to 7AIV, we are asked to find the sum of the first 20 terms. Use the equation for the sum of an AP, which is given as n over 2, Sn equal to n over 2, bracket opens 2A plus bracket opens again, n minus 1, bracket closes D, then bracket closes finally. And n is 20, A is 11, common difference D is 4, already obtained for the former solutions. Then sum of the first 20, that's S20 equal to 20 over n, that is substitution using n as 20, bracket opens 2A, that is 2 times 11, plus bracket opens again 20 minus 1, replacing n with 20, then bracket closes, then D, which is now 4, bracket closes. Then 2 into 20 is giving us 10, bracket opens, 2 times 11 gives us 22 done, plus, then the expression 20 minus 1 gives us 19, and 19 times 4 gives us 26, bracket closes. Then we'll move 10, bracket opens, 22 plus 76 gives us 98. Then 10 by 98 to give us 980 as our final answer to this question. Move to question number 7b that says the third term of a geometric progression GP is 24 and its seventh term is 4 whole number 20 over 27. Find its first term. So go to the solution. The near term or a particular term for a GP has the formula Tn equal to A R n raised power minus AR raised power n minus 1. Then the third term, especially equation for the third term, replacing n with 3, we have T3 equal to AR, then 3 minus 1. That gives you AR raised power 2. We're told that the third term of the GP is 24. So we're going to say AR raised power 2 equal to 24. That becomes equation 1. Then we get an equation for the seventh term. T7 equal to AR. Replace n now with 7. We'll now have AR 7 minus 1, which will now give us AR raised power 6. Then AR 6, which represents the seventh term, is equal to 4 whole number 20 over 27, giving the equation. Then that will give us, converting that 4 whole number 20 over 7 to an improper fraction, 27 times 4, that gives us 108. Then plus 20, that gives us 128. So we now have AR6 equal to 128 over 27. That becomes equation 2. Then dividing equation 2 by equation 1. Equation 2 by equation 1. So we now have AR6 over AR2, AR raised power 6 all over AR raised power 2 equal to 128 over 27 divided by 24 over 1. A eliminates A. Will now come down and have AR raised power 6 over R raised power 2 equal to 128 over 127. Multiply, that is changing that division sign to multiplication and inverting 24 over 1 to become 1 over 24. We now have R6 minus 2, obeying the law of indices, taking 2 up. R raised power 6 minus 2 equal to, when we simplify this by division, we're going to have 16 over 81. Then 6 minus 2 up there gives us 4. R raised power 4. Then 16 is 2 raised power 4. Y 81 is 3 raised power 4. Then that will still give us the same thing as saying R raised power 4 equal to 2 over 3 bracket raised power 4. Then equating terms, R becomes equal to 2 over 3. Then from equation 1, we know that R raised power 2 is equal to 24. Then making A the subject, A now becomes 24 all over R squared. So replacing our R with 2 over 3, that's substitution. We now have A equal to 24 all over 2 over 3 all squared, which is 24 divided by 4 over 9, which is 24 over 1 times 9 over 4. And that will give us 54 as our first term in this question. So move over to question number 9 in the same section B. Number 9 says an aeroplane flies from A, latitude 40 degree north, longitude 38 degree west, to another time B, latitude 40 degree north, longitude 22 degree east. Full stop. It later flies to a third turn C, latitude 28 degree north, longitude 22 degree east. Calculate the A distance between A and B along the parallel of latitude. So let's look at this question number 9A before we start looking at the other ones. A says distance between A and B along the parallel of latitude. Okay. B says distance between B and C along the line of longitude. C, average speed at which the aeroplane will fly from A to C through B if the journey takes 12 hours, correct to 2 decimal places. And we are asked to take capital R, rays of the earth, as 6,400 kilometers, and then pi as 3.142. So we'll start with 9a, which says find the distance between A and B along the parallel of latitude. So we'll first of all find the angular difference between the longitudes of A and B. We'll call it theta. The difference is obtained by adding the values together, adding their longitudes together. 28 degree west, 38 degree west plus 22 degree east. So add them together, we'll have 60 degrees. Then the common latitude, which we call alpha, which both of them have, they lie on the same latitude, which is 40 degrees. So distance AB along the parallel latitude given by theta over 360 times 2 pi r cos alpha. So substitution takes place. We now have 60 over 360 times 2 times 3.142 times 6,400, 6,400, which is raised to the earth, then times cos of latitude, that is cos 40. Solving out to have 60 times 2 times 3.142 times 6,400 times 0.766, which is the value of cos 40 over 360. Then manipulating that, we have the final answer as 5,134.45 kilometers to 2 decimal places as our answer. Go to 9b. That says we should find the distance between B and C along the line of longitude. So we'll find the difference between their latitudes. For B lies on latitude 40 degree north and C lies on latitude 28 degree north. So since they lie on the same hemisphere, northern hemisphere, the difference is obtained by subtraction. Now have 40 minus 28. That gives us 12 degrees. Then distance between B and C along the line of longitude, again by theta over 360 times 2 pi r. We're going to be 12 over 360 times 2 times 3.142 times 6,400. So if we split values, we're going to have 2 times 3.142 times 640 over 3. That's after simplification of values. And that will give us, multiply the numerator, will have 4021.76 over 3. So when we solve this, we arrive at 1340.59 kilometer. 1240.59 kilometer. We'll now move to question number C, 9C, that says we should find the average speed of the plane from A to C. So we have to first find the total distance traveled from A to B and then to C. So by adding the distances we calculated in question A and B, we have 5134.45 plus 1340.59. Adding, we have 6475.04 kilometer. Then speed is distance over time. We now have 6475.04 kilometer over 12 hours. And that will give us speed as 539.59 kilometer per hour. We now go to number 10. That says 3 towns P, Q, and R are such that the distance between P and Q is 50 kilometers and the distance between P and R is 90 kilometers. Full stop. If the bearing of Q from P is 0.75 degrees and the bearing of R from P is 13 degrees, find the question A, distance between Q and R. Question B, bearing of R from Q. We'll go to the solution. We'll have to first of all draw the diagram for the bearing. can see the location of P, see the location of R, and you see the location of Q. P, R, and Q. So bearing of Q from P is in 5 degrees. You can see that. So if here is 75, the other place is 75 degrees by virtue of alternate angle. The remaining angle here in the first quadrant will now become 15 because 75 plus 15 give us 90 degrees. And the bearing of R from P is 310. You measure bearing from 0, you move round to here is 310. So if this point gives us 310, then the remaining angle will now become 360 minus 310, that gives us 50 degrees. And then the angle remaining here from 50 is 90 minus 50, giving us 40. Okay, so we'll draw a diagram perfectly and draw it very well. So we're looking for the distance between R and Q in the first question. Let's call that distance small s. Then find the middle angle here. We'll now add 50 and 75. That gives us 125 degrees. Then go into the solution. We'll say let that distance QR be equal to S, which you're looking for. Applying cosine rule, which is small q squared. Small q is the side facing angle Q. Look at angle Q here. So small q represents this side, that is 90 kilometers. And small r, this is angle R. Small r represents this side, which is 50 kilometers. So small r, the side facing angle R, 50, the small r. While small q is 90, the side facing angle Q. So we now have QS squared equal to Q squared plus R squared minus 2Q bracket R cos P. And that we're applying cosine rule. Then making substitution, S squared becomes equal to 90 squared plus 50 squared minus 2 times 90 times 50 cos P. That is cos 25. Cos of the angle of P is 25. 125, sorry. Then S squared, 90 squared gives us 8100 plus 50 squared is 2500 minus 2 times 90 times 50 gives us 9000, and cos 125 is written as negative cos 55. Then 8100 plus 2500 gives us 10,600. Then minus times minus in bracket gives you plus. Then 9,000 bracket opens, cos 55 is 0.5736. So S squared gives us 10,600 plus 9,000 times 0.5736 gives us 5162.4. So adding 10,600 to 5162.4 gives us 15,762.4. Then making S the solve by taking square root on both sides, S becomes square root of 15762.4, and that will give us 125.5 kilometers. So we now go to the second question that says find the bearing of R from Q. So first of all, we have to find the angle theta, the angle at Q. We have to find that angle theta, the angle at Q. So go to the solution. Applying sine rule, Q over sine theta equal to S over sine P. That is sine rule. Then we'll have 90 over sine theta substitution equal to 125.5 over sine 125. Then making sine theta the subject, sine theta now becomes 90 times sine 125 all over 125.5. Then sine theta now becomes 90 times 0.8192, which is sine 125 all over 125.5. Then that gives us 73.728 all over 125.5. So we divide 73.728 by 125.5, we get sine theta as 0.5875. Then theta becomes sine inverse of 0.5875, and that will give us 35.98 degrees. Then bearing of R from Q will now become 180 plus 75 plus 35.98. And that gives us 290.98 degrees. So since the bearing the thread is expressed in 3-digit form, so we have approximately 291 degrees at the bearing of R from Q. We move to number 6. Number 6A says the quantity Y is partially constant and is partly constant and partly varies inversely at the square of S. I says write down the expression between S and Y. Question I says when S is equal to 1, Y is equal to 11, and when S is equal to 2, Y is equal to 5. Then find the value of Y when S is equal to 4. Solution, this is a partial variation which must have two constants. So we say let A and K be equal to constants. So the number one question, the equation or the relationship between them is now giving us Y equal to A plus K all over S squared. Y equal to A plus K all over S squared. The relationship between Y and S. So go to number 2. CAII. So when Y is 11, we make substitution, replacing Y as 11 equal to A plus K all over. Then S is given us 1. So if Y was given us 11, S is given us 1. So substitute Y is 11, and then under the K we have S, which is 1 squared. So we now have 11 equal to A plus K, because 1 squared is also 1. So that 11 equal to A plus K becomes equation 1. Second condition says that when Y is 5, S is 2. So replace Y in that relationship with 5, and then S with 2. We now have 2 squared under K. So 5 equal to A plus K all over 2 squared. So we arrive at 5 equal to A plus 2 squared is 4. So 1 over 4 is nothing but 0.25K as equation 2. Then we subtract equation 2 from equation 1, that is solving by simultaneous process, elimination process of simultaneous equation. So this is equation 1, 11 equal to A plus K. Equation 2, 5 equal to A plus 0.25K. We subtract 11 minus 5 gives us 6. A minus A is 0. We eliminate A. Then K minus 0.25K. Subtract the coefficient, that is 1 minus 0.25 gives us 0.75K. Then making K the subject, K becomes 6 all over 0.25, which is all over 0.75. That gives us 8. Then from equation 1 says that A is equal to 11 minus K. So for equation 1, we'll make A the subject. Yes, so A becomes 11 minus K. And since we're getting K as 8, we'll now have A equal to 11 minus 8. Substituting K as 8, we now have 11 minus 8, that gives you 3. A is 3. So the constants, A is 3 and K is 8. We'll go back to the variation equation, Y equal to 3 plus 8 all over S squared. That variation law, replacing A with 3 and replacing K with 8, we'll have that. So Y equal to 3 plus 8 over S squared. Then when S is 4, what do we do? We'll now replace from the equation, given that S is 4 from the equation. So when S is 4, replace S with 4, we'll now have 3 plus 8 all over 4 squared. That gives us 3 plus 8 over 16, because 4 squared is 16. 8 over 16 is 1 over 2, which is 0.5. So we'll have 3 plus 0.5, and that will give us 3.5 as our answer. Y equal 3.5. We'll now go to question 6b. That says an item was sold for 750 naira, 650.00, with a profit of 30%. what would have been the selling price if a profit of 20% was expected? An item was sold for 650 naira, 650.00 with a profit of 30%. What would have been the selling price if a profit of 20% was expected? Solution: percentage profit gained by profit all over cost price times 100/1. And then profit itself is nothing but selling price, that is SP minus cost price, which is going to be SP minus S, taking our cost price to be equal to S. Then from the equation or given to us, the selling price is 650 naira. Percentage profit is 30%. They will substitute in the above equation. We now have percentage profit 30%, that is 30/1, equal to the profit, which is selling price, that is 650 minus cost price, which is taken as S,